assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
This question asks us to consider the exothermic reaction where C2H4 and Cl2 join to form C2H4Cl2. And then it asks us, if you were trying to maximize the amount of C2H4Cl2 produced, which tactic might you try, assuming the reaction mixture reaches equilibrium? And these are the four possible ways to maximize C2H4Cl2. Let's go through each of them. Increasing the reaction volume. For this option, it's important to note that volume and the number of moles of gas are directly related. That is, if you increase the volume of the reaction, you're going to shift the reaction towards the side that has the greater number of moles of gas, as if they have more space to spread out in the new, larger container. In this reaction, we have 2 moles of gas in the reactants, 1 each of the 2 reactants. In the products, we only have 1 mole of gas in this one product. So if we were to increase the volume of the reaction, we would shift this reaction to the left because there are a greater number of moles of gas there. And this would not give us any more C2H4Cl2. So A is not one of the ways to increase the amount of product. B says to remove C2H4Cl2 from the reaction mixture as it forms. So if this reaction proceeds from left to right, and we form C2H4Cl2, eventually it's going to reach equilibrium. But if we remove a little piece of C2H4Cl2, we will then shift the equilibrium back towards or further towards the products. As we continue to remove the product, we're going to basically place a hole on that side of the equation that needs to be filled. So the reactants will constantly be flowing towards products because we keep taking away the products, so it's trying to balance out the equilibrium every time. So if you do what it says in B, you will continue to shift the equilibrium towards products and you'll continue to make more C2H4Cl2. So B is one way to shift the reaction towards products. C says to lower the reaction temperature. It tells us that this reaction is exothermic, so you can think of heat as another product, that you form heat when you do this reaction. If heat is a product and we lower the temperature, it's as if we are removing product from the reaction. And just like in B, as you remove product, you shift the reaction towards the product like it's trying to fill that hole and reestablish equilibrium. So C would shift the reaction towards products and would generate more C2H4Cl2. So C is also an option. D says to add Cl2. Cl2 is a reactant, and when you add more reactants, you shift the reaction towards the other side of the equation as if you have too much on one side and you need to push it off to the other side to balance the two sides out. So adding more reactants shifts the reaction towards the products and you would form more C2H4Cl2. So D would also get you more product. So B, C, and D are the 3 ways that you can maximize the amount of C2H4Cl2 you produce.